So we continue with the example of we are still in small sample, but now for unequal. Okay, for unequal. So I will show you the example 8.4, page 138. So the question here is assuming that two populations are normally distributed with the unequal and unknown population standard ratio, construct a 98% confidence interval. So that is 98%. So therefore your alpha is 0.02, and it gives you the all the things that we need here, which is n1 is 13, n2 is 19, and then s1 bar, s2 bar is equal to 52.78, 45.55, and then s1, s2. Okay, 3.55 and 5.28. Okay, so you need to construct at the 0.02. So class, this is the case where this unequal is already mentioned in the equation, is unequal. So mu1 minus mu2 equal to x1 bar, okay, minus 2 bar, plus minus, okay, we are still using t alpha over 2 because this is small sizes, and then s1 bar minus s2 bar. Okay class, so okay, we fill up this one first. So 52.78 minus 45.55 plus minus t alpha over 2. So your t alpha over 2 is 0.01, comma, what is your degree of freedom? Okay class, so when it comes to unequal, so it's quite complicated to get the degree of freedom for unequal. Okay, if you can refer to the slides or your notes, the degree of freedom for unequal is given by this formula. Okay, it's quite complex. Okay lah, okay, it's quite complex. Over s1 square. I also hate it. Confused. I'm not confused, but I just worried that if you do the mistake here, because it's quite messy for me. The formula is layer, so many layer. Okay, so this is the formula to get your degree of freedom for unequal. Okay, for unequal. Therefore, you need to find this, all these things first, then you get you start substitute here. So okay class, so I just write the final answer that we get. So you can do it by one by one. You substitute s1 here. Actually, it's easy, but it's tedious. Yes. Okay, all the information already given. So you just substitute here and then you calculate carefully. Okay, calculate carefully. Okay, please avoid to do it careless mistake, because sayang lah if you calculate wrongly and you get the wrong answer for your degree of freedom, even though it's a small thing here, just here, just to part here, but it will affect all the calculation later on. Okay, so you will get the 30.0025 and is equivalent to 30. Okay, because it's 30, 2.5 is in the behind, so we take the, I mean, it's obviously it's a 30, so we get the degree of freedom 30. Right, so by using table, so again using table, so 0.01 and the 30, so 2.457. Yes, 2.457. So how about your SS1 bar as well? Okay, this one simple compared to the equal. Equal is quite complicated, right? You need to find your SP and so on. But for unequal, is simple. It's fair. For equal, you need to find SP and so on. But for unequal, you need to do the degree of freedom. Is quite complicated lah. Okay. So for this one, actually, it's just simple like we have done in large sample. Okay. Okay. Alright. So you can proceed this one with just substitute s1, s2 and so on. Then after that, okay, this one will be 52.78 minus 45.55, 7.23. Okay, plus minus 2.457, and then this one you will get the value of 1.5610. Okay, I just directly from the textbook. Okay, so the final answer is 3.3946 and 11.0654. So basically, okay, after we do all these example and so on, I hope that you realize that actually it's simple. I mean, it's because the step is already what I want to say. We just follow the steps. Dia punya step sama je. Cuma of course lah, dia punya figure or numbers is different. But what I want to say here, from chapter 5 is quite different. Okay, from chapter 6, chapter 7, and until chapter 8 now, the things is similar. So nothing. You just you just make sure that you read the question carefully. That's it. So from the question you read carefully and then you digest, you summarize, you extract the information, then you can proceed with your steps or your what you call your script or answer. Okay, alright, so we continue back. So this is the answer. Okay, so now we proceed, or I give you another one example, which is exercise 8.6. Okay, exercise 8.6, page 139. Okay, I read the question here. Okay, it's quite complex. That's what I mean. The how we answer it, the steps or the answer that we done it. If you can see that it's just simple lah. Okay, it's just we know that we want to find what. Okay, we want to find SP or yeah, Z alpha beta and so on, and then we substitute into the formula, then we get the answer. But the critical part here is when you get the question, because maybe you will down or you will, because for me also when I get the question that to read a lot like this kan, so dia macam is I'm not sure whether you are feeling like what I feel, because when I have maybe because I'm mathematics, more to maths or calculation, so I hate when we get this type of question like this. It's too many things to read, but actually it's just we just take the main or the numbers only. Okay, alright, okay class, so I just continue back. So the question here is, a manufacturing company is interested in buying one of two machines. The company tested the two machines for production purpose. The first machine was run for 15 days and produced. Okay, so the N1 here is 15, and then average is 111, with the standard size is 10. The second machine was run for 18 days and produced, the average is 118 with a standard size 8 items. Assume that the production per day for each machine is numerically and the standard deviation of the daily production of two machines are unequal. So it's unequal. Okay. So A, make 95. Okay, class. So my textbook, my version is 95%. So I hope that you can change it. We change it, become 95%. Confidence interval for the difference between the two population. So your alpha will be 0.05, right? So you need to find, okay, we find first T alpha over 2. So it will be T 0.025, and then of course your degree of freedom. So what is your degree of freedom here? So you need to do it lah. Okay, I hate alright, so yeah, so I hope that you can do it. You just substitute all the thing here into the formula. Okay, so because I already done it before. Okay, I done it before, I show you. So from my calculation, I get my degree of freedom is 26. So you can do it by yourself, then you check with my answer. Okay, I get my degree of freedom is 26. Okay, so therefore by using table t-test 0.025 and 26, so it will be 2.056. Okay, alright. Okay, so we can continue now. X1 bar minus X2 bar plus minus T alpha over 2 and then S1 bar minus S2 bar. Okay, so S1 minus ni, so 111 minus 118 plus minus 2.056, and then this one, okay, you need to find out all this lah. 1 plus N2. Okay, so this one will be negative 7, right? 1111 minus 118, negative 7 plus minus 2.056, and then this one 3. Okay, I done this now. 3.1972. So the interval that you should get here is negative 13.5734 and negative 0.4266. Okay, right. So this is the for A lah, question A. So now B. Using the 1%, okay, 1% significant level, can you conclude, okay, so this is the hypothesis testing. Can you conclude that the mean number of items produced per day by the first machine is lower? It's lower, okay, it's less than, okay, it's lower than second machine. Okay, class, so this one quite different lah compared to the previous example that we have done before. So now, for H1, okay, for H1, it said that your mu1 is lower, so means that minus mu2 less than 0. Okay, lower. So you must do the less than equal lah, that's less than sign. Then automatically your H naught will be mu1 minus mu2 is greater than equal. So they have equal sign. Okay, they have equal sign. Alright, so this one is step number 1. Step number 2, you need to find your test statistic. So this one minus mu1 minus mu2 and then divided by S1 bar. Okay, when it comes to hypothesis testing, actually is nothing much that you will do because you already calculate all this. For example, this one S1 bar, you already calculate from here, so negative 7, and this one is automatic equal to 0. Okay, and then S1 S here you can get it from directly from the previous one. Okay. Right, so therefore the test statistic or Z value here is negative 2.1894. Okay, next step number 3. Your alpha just now is 0.01. Okay, class, please don't get confused. Jangan pula guna this value. This value is for A part just now, but now we will do it for B. So question B asks you to using the 1% significant level. So 0.01, and then the degree of freedom also the same like we have done before, 26. Okay, then the T table, the T is just T alpha. Okay, it's not T alpha over 2 because this is one tail. So T 0.01 with the 26. So you need to find the what you call the table now. 0.01 26. 0.01 26. 2.479. 2.479. Then you plot the graph. Oh no, you're sketching the graph. So since this is less than, so it will be the left side, right? Left side. So this is your this is your rejection region. So then check whether negative 2.1894. Okay. Yes, class. Yes. Even though you will get positive, but since this is less than, so therefore the graph should be on the left side. So you should put a negative sign here. Okay. So you check whether negative 2.18 here is lies under the region or not. No, because negative 2.18 is greater than negative 2.4. Okay. So means that it's not lies in the rejection region. Therefore, we will accept H naught. Okay, we will accept H naught. So I'm not sure whether you can see or not, but yeah, you just listen to my voice. So we will accept H naught. Then the conclusion that you can make is, can you conclude that the mean relation? Okay, so we accept. So means that the mean of the not lower means that we can conclude that the mean for the first machine is not lower. Okay, is not lower than, okay, so the keyword is the mean for first machine is not lower than the second, because we accept we accept H naught, okay, we reject our H1, right? So the keyword here is we didn't accept, the keyword here is the mean for the first machine is not, okay, the keyword here is not lower than the second machine. Alright, okay, you continue lah the sentence. Okay, so class, so we'll stop here, and then I will continue with the last example with for the what we call for the proportion. Okay, for the proportion. Okay.